Hi, I'm Kayla.
And I'm Lisa. And we're here on a material science mission to model the microverse.
Ooh, like Ant-Man the Microverse?
No, even smaller, maybe the nanoverse. We're talking about materials as thin as one atom thick.
That is thin, and when they get that thin, they're called two-dimensional or 2D materials, and they have special properties that scientists play with.
And that you can play with in this activity.
Yeah, because you'll be playing with your food.
Is Jell-O food?
I think so.
So, here's the plan. We're gonna model a 2D material with Jell-O. Explore some of the same features that scientists observe in microscopes. Way too small to see with our eyes.
Then take what you learned and build and test a new design for a particular task.
Here's what you'll need. Jell-O, hot water, cold water, a bunch of paper plates. Make sure they're the coated kind.
A plate for every design you can imagine.
We're gonna start our design with rice, cereal,
Something chunky, like Chex or something similar.
and milk.
You'll also need everything to mix up Jell-O: a measuring cup, mixing bowl, and spoon. And you'll need a baking tray and a knife, small cup for pouring milk, pen or marker, paper for design plans.
Okay, so get some help from an adult to make the Jell-O.
Now let's prep 4 plates of our 2D material, Jell-O, spooning just enough to cover the bottom of the plate.
Use our instructions to get it right. You can download them from the link. We're gonna chill this first plate untouched. This will be our first model material, a 2D material with a perfectly smooth structure.
These next 3 plates, we're gonna mess them up, what scientists call adding defects.
So, on plate number 2, I'm sprinkling some rice. These represent tiny defects.
Plate number 3 gets pieces of cereal. Those represent large defects.
We'll come back to plate number 4 after it's chilled. So let's chill them all.
Ooh, they look good and ready.
So time to mess up plate number 4. I'm cutting long lines through the Jell-O in different directions. The lines represent another type of defects called grain boundaries, which are the edges between different sections of a material. There.
Okay, you now have 4 different 2D material models, and you're going to observe how each affects the flow behavior of milk.
Milk? We're gonna pour milk on them?
That's right, you're gonna pour milk on your Jell-O.
Just prop up your plate on the edge of your baking tray, and we're ready to go.
Okay, so in this model, the flow of milk represents something like heat or electricity, something that moves through the material. And we're going to start with a plate of smooth Jell-O, pouring the milk from the highest point of the plate. Here goes.
Just as I thought, the milk flowed straight down the smooth Jell-O.
Now on to plate number 2. Let's see how those defects change things. Ready? Psych, you have to do it yourself.
Go ahead, test those other plates, and then come back.
And go for it. And we're back. What did you observe? How did the different defects affect the flow of the milk?
And what path did it take?
And where does the milk first reach another edge of the plate?
Material scientists know that in these very thin materials, the type of defects, the number of defects, and their location determines how they behave. And that's really important. Just like a chunk of cereal might completely change the direction of the milk flow.
Okay, so now that you've observed how different 2D materials are in a model, you're ready to design your own.
Your challenge is to build a material that can control the flow of milk from one point to another.
Yeah, make some more plates of Jell-O. Mark a point A up top here and a point B about 1/3 of the way down. Now create your material using any combination of defects.
Rice, cereal, cuts with a knife.
Think about what you saw in your test and see if you can design a model that gets the milk from point A to point B.
Scientists design materials with defects on purpose to make them behave in certain ways too.
Just like you're gonna do.
So get together, strategize, draw out some plans, and give it a shot.
I'm not throwing away my shot.
Well, it might not work the first time.
Then I'll try again.
Failure is a great teacher.
Oh, I know.
You failed before?
And I fell again.